Good afternoon. How are you guys doing? Hello, hello. We'll do our Mindfulness Monday after a few minutes when more people arrive. In the meantime, I'll let you look at something. How'd the midterm go? I have not looked at them yet. I mean, I did all your oral ones, so I know how that part went. Somebody give me some info about the Canvas portion of the midterm. Fine, bad, good, terrible, average. Tell me anything you got. What'd you think? You're like, well, you didn't look at it yet, so I don't want to answer. It's okay. It's okay that I didn't look at it yet. It went all right. Thanks, Kelsey.
I feel like I did a lot easier than the other midterms the last semester.
Nice. Anyone agree with Bethel? No, everybody else was terrible. It was terrible, Bethel. So we don't know. I'm so happy it went well for you. Everybody else says Bethel.
I mean, it was easy, but like it doesn't mean I got a good grade.
Okay. All right. I'll take a look at them as soon as I can. You can see I have some stuff to grade. I still have your team counting assignment, right? I have that investigation to do, which did I send you a peer review thing for that? Okay, I feel like I did because I have to look at those first and then I grade the team assignment and then I'll grade your midterms. All right, I don't even know if I sent you an email. I was trying to send you an email, but maybe it was too late. I don't even know if again, it's Technology Monday, fun days. So yeah, there you go. Thank you, Bethel. Thank you, Elena. If you have one of these items laying around, just one of these, grab it so you have it handy. You literally need one. We'll talk about it in a few minutes. If you don't have one, it's not a deal breaker. You're good to go. Okay, so no worries. You guys were getting so close. Are you feeling it? Now, which means you guys still have a lot to do, right? And if you looked at the assignments this week, were you crying? We're like, what is happening? Why are there 50 assignments this week? Is this lady lost her mind. No, it's okay. A lot of these we'll do in class and a lot of them are pretty short. The reason I like them, the reason I made you do them is because it's good for you to have these in your notebook handy, you know, for when you do stuff. By the way, I have a question while we're waiting for a couple more people to get here. Are you guys liking that I'm sending you an announcement on Friday? Do you like that I send you a message? Or do you care? Okay, I got 3 yeses in that, I think. Some of you are like, message? I don't read them anyway. It doesn't matter. So you're good. Just kidding. Or some of you are like, I was reading them without you sending me the message. Now it's just seeming annoying. Okay. Because I just found like some people were not reading them or I suspected they weren't reading them. So it was kind of my nice way to check in with you on Friday and give you a preview of what, you know, things are going to look like. Sorry, I didn't have all the slides ready. So we're just a tiny bit off because of where our midterm fell, because of our extra week of fun there. I don't think it was fun, but it was an extra week. So, okay. So, I still have 1, 2, 3 people, and I don't really want to jump into our Mindfulness Monday and then hear the ding dong the whole time because that's very annoying to me. So we're going to wait a few more minutes on that. First, let's talk about some vocab. By the way, did you see my train on the virtual classroom? Did you like the train? Yeah, you're welcome. Those were from our attribute trains from last week. I know you appreciated them. These are the little things I do to make work a little bit more fun, right? Okay, what graphic can I put in this week? But I have to be careful, make sure I pick a appropriate one because there's a lot of inappropriate ones, right? You got to be careful when you're looking at those. Okay, so we talked about attributes of things and we talked about mathematical versus non-mathematical attributes. And now we have to talk about the building blocks of geometry. And there's 3 major building blocks of geometry, points, lines, and planes. So, and these are problematic for students because we know what a point looks like if we put a dot there, right? We go, oh, that's a point. But that's not really what a point is, right? It just describes a location in space and it's drawn with a capital letter. Like there's points all over here right now, but I don't have dots all over here, right? So you have to be careful when you think of geometry. Lines are determined by 2 points and we have them with arrows at both ends. So for example, this is a line because I've designated these arrows here. If I didn't have those lines there and I had dots, it might be considered a line segment, right? Which is part of a line. And we can name it in more than one way. We can name it by 1 lowercase letter or 2 uppercase letters with a line over them with arrows at both ends. So for example, I think that's an L. We could call it line L, right? Like that. That's a line, line L. Or we could say it is line AB, or it's line AC, or it could even be line BA, right? Or it could be BC. I mean, we could come up with more combinations of it. But when I'm saying a line, I just have to define it by 2 points. Okay. As soon as I draw any 2 points, I could connect a line as long as they're in the same plane. And that's what we're going to talk about in just a second. Okay. Planes are determined by 3 non-collinear points. What on earth does that word mean? Non-collinear. Anyone know what that word means? Yeah, they're not all on the same line. Okay, so if I look at this line here, A, B, and C are collinear because they are all on the same line. Okay, so a plane is not defined by these 3 points because they're all on the same line. But do you notice these 3 points, A, B, and C, are not on the same line? I would have to draw another line to go through point C. Okay, so non-collinear means they're not on the same line. We usually draw these planes like slanted like this. And we name them by 3 points at least or a Greek letter. Okay, that's how we name planes. So just when you're reading through things, there's a reason we have notation the way we do, so we don't get confused. Okay, we could have line segments. There's a line segment. Notice now that we don't have arrows on the end, we have dots on the end. Okay, if I had this A and B, I would just go A, B with a line over it. Notice it doesn't have arrows on the ends. That just means it's a line segment. Okay. Array has an endpoint at one end and then an arrow at the other end. So if I say, usually we have 2 points still. Let's call this F and G. So if I call this array F and G, I could draw it like that. But now order matters. I can't call it ray GF. I can't call it ray GF because my endpoint is at F and it continues through G. So you have to be careful. And then a vertex is where two segments or rays intersect. So that's just some vocab review for us. And you have a video assignment that's points, lines, and planes, and then you have a worksheet on that too. It shouldn't take you very long. I would say that whole activity would probably take you 20 minutes at the most. Okay. All right. So, and then we have angles, and we'll talk about angles more in just a minute. So vocab is heavy, heavy, heavy in geometry. Yeah, really, really heavy. And you have to be very precise in your vocab. So be very careful. If you really struggle with it, I have some Quizlets in there that you can use for review. Or you can make your own flashcards or vocabulary page in your notebook. I've tried to help you with some, foldables or graphic organizers for that. Okay, so now we're going to do our Mindfulness Monday. Maybe. One moment, please. Okay. So I'm going to share my screen. I really needed this today. If you don't really need it today, well, just appreciate the fact that I need it, because I did really need it today and do need it today. And you can turn your cameras off if you need to. It's okay. I was just going to email you the thing instead of share my screen. I don't know what is going on, but we're good now. Okay. And it is 5 minutes, but I really, really, really think it's worth our time.
Thank you for joining me for this 5-minute guided meditation to practice resiliency and focus on peace and healing. As always, let's begin by finding a quiet and peaceful place to meditate and assume a comfortable upright position. Closing your eyes, as you take in 3 deep breaths, bring in awareness. Breathe in and feel the oxygen fill your lungs as your chest expands. Breathe out, feel your chest fall. Breathing in, become aware of the weight of your head as it sits comfortably on your shoulders. Breathing out, let your shoulders relax as you pay tribute to each part of your body. Acknowledge your arms, your hands, your fingers. As you breathe, recognize your chest, your stomach, your posterior. Move down to your legs, your feet, and your toes, and find peace in the knowledge you are whole and safe where you are right now. Continue with your breath and repeat these phrases to yourself. I will be kind to myself today. I will find peace and healing today. I am doing the best that I can in this moment. I will accept that change is a part of life. I have hope for the future. Life right now may not be what we planned. There is disappointment and sadness, but there is also love and light and hope. Practicing compassion to ourselves and to others will help us overcome. Whatever disappointment or sadness that has taken up space in your mind, let it go and repeat the phrases. I will be kind to myself today. I will find peace and healing today. I am doing the best that I can in this moment. I will accept that change is a part of life. I have hope for the future. Feel the peace and calm all around you. And take in a deep breath as you start to wiggle your fingers and your toes. Move your head from side to side. When you're ready, open your eyes and carry this compassion for yourself and others with you throughout your day. Thank you.
All right. So I don't know if you needed that, but I definitely did. So welcome back. I think right now our lives are crazy, crazy, and they're getting busier and busier, and we need to stop and take 5 minutes to really think about where we are and where we're going. So it's easy to lose sight of that. Okay. So hopefully you didn't fall asleep. Maybe you needed a 5-minute nap. I'm not sure. But now, if you have this, get it out. If you have one of these, get it out. All right. It didn't have to be this color. And if you don't have one, it's totally fine. I'm introducing to you the most amazing tool you've ever seen in geometry. Right here. This is it. It is called an angle finder. I don't think you can see that. There you go. It's called an angle finder. Yeah, it is. This is the first tool that you're going to need when you're finding some angles. So I can see some angles on this. I can identify some angles. We're going to talk about, we defined an angle just a tiny bit by, it's formed by two rays with a common vertex, but we're going to have some other definitions we're going to investigate in just a minute. Do you know any angles? Do you know the names of any angles? Yeah, you only need one. You need one. I thought you were naming our angle with your last word. So does anyone see a right angle on this card? Ah, what's a right angle?
90 degrees.
Yeah, 90 degrees. Well, 90 degrees is right here on our handy dandy angle finder. And we call it a right angle. And we can do 90 with a little circle around it. That's what I did on my angle finder. So when I'm finding an angle, I can put this little corner right here, this corner right here down right at my angle. And I can say, oh, I found one. I found a 90-degree angle. So look around your room right now, wherever you're at, whatever room you're at, look around your desk, whatever. Did anyone find a right angle somewhere? Yeah. Where'd you find one, Tyler? Where was it?
My computer screen.
Yeah, nice. And you could take your handy dandy angle finder and put it right up on that computer screen and go, oh, fits there perfect. Must be a right angle. Yeah. All right. And then I saw in the chat, I saw some other words. I saw obtuse and acute. So do we know what either of those are? Somebody give me some kind of definition.
I think obtuse is anything above 90 degrees. The angle would be obtuse.
Okay, nice. So an obtuse angle is greater than 90 degrees. Now, make sure we use the right symbol, right? When we do greater than 90 degrees. And you have to be careful, and it should be, and I'm going to write in greater than. And it should be less than 180 degrees. And the reason I want to put that disclaimer in there is we do have a different word for angles that are bigger than 180 degrees. By the way, is that backwards to you? Okay, good, because it's not backwards to me either. Just making sure. I didn't want you crying out there writing your symbols backwards. Notice obtuse has an S in it. O-B-T-U-S-E. That's how we write obtuse. So how would I use my angle finder? I'll keep this up here for a minute, sorry. How would I use my angle finder to find an angle that's larger than 90 degrees? Well, I already know that this corner right here is 90 degrees. So how would I be able to tell using this amazing tool of an angle finder, know that it's bigger than 90 degrees? Any ideas?
Well, if your angle finder doesn't completely cover the object of the angle you're measuring, then it's bigger than 90.
Genius, genius. Let's see if I can do it in this backwards town. Probably not. This is like a huge puzzle for me. Maybe if I do this. Okay, so I put this right here on this bottom ray. And I can still see part of the angle. Well, then it's definitely bigger than 90 degrees. So this must be an obtuse angle. Yeah. So my angle finder did it again. I found it. Yeah. Amazing. Okay. How about an acute angle? What is an acute angle?
Less than 90 degrees.
Nice. Less than 90 degrees. Now, how would I use my angle finder to show that an angle is less than 90 degrees? Let's use Hannah's idea there. If I completely cover it, the other part of the ray must be underneath there. Yeah, it's underneath there, so I can't see it. There's my bottom ray. Where's my other ray? Oh, there it is. I know, it's amazing. It's amazing. So this angle finder just found acute angles for me. Look around your room right now. Do you see obtuse or acute angles anywhere in your room? You see any? I can see one in Madison's room. Behind her where those posters are, do you see where those posters intersect? There's a space between there. Madison could run over there and put her angle finder on the wall and prove to us if it is acute or obtuse, but Madison might not have an angle finder on her. It's okay. Do you have a piece of paper that can be your angle finder? Do you have a Post-it note? How about that? There, see? I prefer the more expensive tool right here, the angle finder, but any tool will work, right? Okay, run over there, Madison. Run over there. Can you reach back there on your poster?
We'll find out right now.
Okay, good.
Oh, right here, right?
Sure. There's two angles there, right?
Mm-hmm.
Okay, I want the space between them though, right?
Oh yeah, right here. So right here, yeah, that's gonna be acute.
Very nice. Good. That poster is way higher than I thought it was. Sorry about that,
I couldn't reach it.
I didn't know you needed a step stool. We could have done the angle beneath it too, if we wanted to, where those two intersect. Nice. Now, nobody else is going to say they found any. Everybody else is going to be like, nope, there's none in my house. Sorry. It's not going to happen. So there's one other type of angle that we haven't talked about, and it's right here on our angle finder. What type of angle is this? Anyone know the name of that? You could probably guess.
Right?
Huh, nice. Good job. Yeah, it's a straight angle. So a straight angle. And by the way, these are angles, not angels, right? We're not going to spell them wrong. You'd be amazed at how much that happens, right? So a straight angle is right here, and that's 180 degrees. See it? Straight angle, 180 degrees, not my lips, just in case you thought it was pointing to my lips. That's not what it was supposed to be pointing to. It's the edge of this. Okay, and I can see straight angles and right angles right behind Kelsey on her wall. Can you guys see it? You see those straight angles and those right angles on Kelsey's wall? Yeah, you can. I can see a right angle in the corner on Essay's door. By the way, Bethel, over there behind you on whatever, if that's a piece of art or a clock on your wall that has 4 sides and then a bunch of stuff in between there, there's a lot of angles going on right there, right? Yeah, we could find a lot of angles there. So by the way, very expensive tool right here, angle finder. Yes? Yeah, are you amazed? Yeah, it's amazing. This is an amazing tool. It is. It is a tool that will be your best friend. Literally, we've talked about these things before. And I've had students go, can I use my angle finder on the test? No, you can't. You cannot use your angle finder on the test. So you guys know a tool that looks like this too, right? Which one looks easier to use? This one or this one? Yeah, this one for sure. Don't overwhelm people or kids before they need to be overwhelmed. If you introduce this, before you've introduced this, your students will be crying, right? Some of you are still like, I still don't know how to use this. This is still a mystery to me, right? It's a magical little tool that I don't understand, that I didn't even know was called a protractor. I thought it was called a compass. See, you're laughing because it's true. Yeah. And your teachers always just assumed you knew what you were doing. Did you have one of those teachers who was like, all right, get out your protractors, measure all these angles and let us know what you got? And you just made it up. You were like, yeah, perfect. I'm just going to hold it on my paper for a while, write some stuff down and then turn it in. They're all going to come back wrong. Right. And she's going to go, what's wrong? And you're going to go, yeah, I was just not feeling it that day. And you still don't learn, right? So we're going to spend time on this, making sure we understand this. Yes, which is nice. But this one is our precursor tool. You hand these out to your students. By the way, look, I have more, right? I have another one right here that I've used before. So make them again and again. Have your students make them. Pass them out. But by the way, if you're going to do this, sell it like you mean it, right? Make it your infomercial. right? Have your students make an infomercial about their angle finder, and then have them keep this tool handy. So when they're doing an activity and they're confused about something, you can say, can we use MP, which MP is it, where we use appropriate tools strategically? Do you remember?
MP5?
Thank you. MP5. Yeah, MP5. Use appropriate tools strategically. What tool do you want to use? Some kid will say, I want to get a protractor. And you'll be like, that's fine. You can get a protractor. Some other kid will go, can I just use the angle finder? You'll be like, you sure can. They'll keep these safe. They will keep track of them. What I usually do with my students the day we introduce this is, first of all, I dress up like a person on an infomercial, which they appreciate, right? Yeah, I didn't today. I mean, I kind of did because I'm an infomercial for MCC today, but, and then I pass them out and I tell them, be very careful with them, you know, label them accurately. And then we go on a scavenger hunt, and you can choose how you do it. If you do it in your classroom, or if you do it on the playground, or if you do it around the school, and have them find 3 to 5 of each type of angle, right? Have them find 3 to 5 of each type of angle. And when I said choose where you want to do it, if you have a group that's not necessarily super trustworthy, keep them in your room, right? If it's 110 outside and you don't want to make a trip to the playground, don't go outside to the playground, right? But if you have a group that's really on task and you have a nice little area at your school, send them outside, go outside with them, right? And have them explore. And then as a follow-up activity, I usually send this home with my students, and they do it at their house, and they have to find 5 more. Boy, oh boy, if you let them take pictures, they're all in, right? They love taking pictures and sending them. And depending on their age when you do it, have them do it with their parent too, right? To verify. And the kids really, really like this activity. It's a great scavenger hunt. We did it in our classrooms, like when I have you face to face. The American flag that's in every single classroom has great angles on it, right? It has all of them. It has straight angles, right angles, obtuse and acute angles because of the stars, right? So it's a great way. There's usually an exit sign in classrooms that has all your angles on it. So, and we would have a contest to see who came up with the most unique angle for each category. And my prizes were like, oh, you get to line up first for recess. That's an amazing gift right there, right? Or you get to be the line leader today. Oh, for crying out loud. Don't make it, I'm giving you points for something, because then you have to keep track of those points. That you don't have time for that, right? Okay, so this is your great new tool, your angle finder. Keep it handy, don't lose it. We are going to put something on the back shortly, so don't let it go too far. Okay? All right. So, sorry, I just lost my screen. You do have an angle assignment. I have some angles here for you. See, we have the definition of an angle, what an acute angle is, a right angle, an obtuse angle, a straight angle. And then, oh, we didn't talk about a reflex angle, because you don't usually talk about that in young elementary school. A reflex angle is a measure that's greater than 180 degrees, but less than 360 degrees. So now I want you to think about this. Atticus stated the measure of angle B is greater than the measure of angle A. The sides are longer. Is Atticus correct? Why or why not? What feature of the angle is Atticus focusing on? So think about that for a couple minutes. Get your answer ready in the chat when you're ready, and we'll read everyone's explanation. All right, you got your answer ready? Nobody's screaming no. So here we go. 3, 2, 1, go. Let's read through these once we get them up there. I love when I'm reading through and I get to one that just says he is wrong or he is wrong. Make sure you're working on your vocab, right? Boy, some of you have some nice vocab going on there. Yeah, are you reading everybody else's? Is there anyone you like in particular? First of all, the ones that use Atticus, I really like, you know, because you were really focused in on the problem. Somebody said they like Tyler's. Tyler says he's wrong because he's focusing on the length of the rays and not the measure of the angle. The length of the rays don't affect the measure of the angles. In this case or in all cases? Yeah, all cases. Hannah's. Atticus is incorrect because he's focusing on the rays of the angle and not the vertex, which is the part of the angle that determines its measure. Madison's. I was waiting for someone to say Madison's. Atticus is not correct in comparing angle size. Atticus is focusing on the length of the angle rays and not the angle itself. They are congruent angles or the same angle. Nice. Look at that vocab. Yeah. So, and I just wrote Atticus is incorrect. He's focusing on the length of the rays that form the angle, right? So you guys were even more specific than me. Good job. All right. How about this one? Scout stated the measure of angle B is greater than the measure of angle A. I measured it. C. Is Scout correct? What feature is Scout focusing on? Get that one ready. Okay, you ready on this one? I gave you less time because you're just looking at me weird right now. Okay, 3, 2, 1, go. Oh, I liked essays. Yeah, so Scout's incorrect. He's focused on the linear distance between the points on the rays. And I could have put those points anywhere, right? We could have measured it at any point. Do you recognize those names? Some of you do. Scout and Atticus, what is that from?
To Kill a Mockingbird.
Nice. Yeah. So Can you do that in your math class? Refer to literature names just to see if students are paying attention? Yeah, you'll get a lot more students paying attention when you do weird things like that. Or if you use the students' names. We've talked about that before in 256 when you use the students' names. Okay, so what's the measure of an angle, 1 degree or 30 degrees, actually measuring? You ever thought about it? Thought about that definition of an angle? So let's think about it. We could define it. You'll see all kinds of definitions in a book. A geometric figure formed by two rays meeting at a common endpoint. Or as a wedge or space between two rays. I'm going to skip down to here for a second. So I'm going to put you in breakout rooms in just a minute. I want you to just sketch on a piece of paper. You're not going to turn it in. Some angles, okay? And don't use your protractor. Don't use this guy yet, okay? Just use deductive reasoning and some ideas on, make them as precise as you can without this tool. Without this tool. Everybody clear? So these are the angles I want you to measure. I want you to draw, sorry. I want you to draw 45 degrees, 277 degrees, 58 degrees, 121 degrees, and 18 degrees. And I'll put those in the chat. Okay, so you have them, so you can copy them from the chat if you need to. And try to use a straight edge. So you can use your protractor for the straight edge part, or you could use this amazing tool, your angle finder, right? And sketch those 5 angles and do it on your own. And then I'm going to put you in breakout rooms in about 2 minutes. So then you can compare, how did you do it? What was your procedure for getting as close as you can? Don't measure them, right? Just estimate them. Okay, so your 2-minute alone time starts right now. Except for I lost my timer, so. Haha, found it. All right, so now I'm going to put you in your breakout rooms. It's okay if you're not done, but when you're done, share your ideas on how you did it and share your pictures. You can just hold them up to the camera. I'll give you just a few minutes to do this.
You're on mute.
Thank you, Tyler. Okay, so let's share our things. Who would like to hold up theirs and show us their 18 and tell us how they got 18 degrees in their picture? Don't everybody jump at once. I'm ready.
I'll do it.
Thanks, Hannah.
Okay. Hopefully you can see. So I drew a box to get my 90-degree angle just as a reference, and then I drew a line diagonally to get my 45, and then I measured what I thought was just half of 45, and then I went a little below that to get my 18. So just a lot of like having things. I halved the 90 to get 45, half 45 to get 22.5, and then 18 is a little less than that, so I went a little lower than that.
Nice. Anyone have a different strategy than Hannah? Some of you are like, no, Hannah's was exactly what I did. I didn't do what Hannah did. I divided 90 by 3 and got 30, 30, 30. Did half of 30, which is 15, and then just a little bit more. So similar to Hannah, but instead of using half of 90 to get 45, I didn't see a connection as easily between 45 and my 18 as I did splitting it in thirds and getting 30 and then half of 30. Anyone use something else that they're just now figuring out they used? Some of you are like, oh, we were supposed to be more strategic than just guesstimating. I see your little smiles. Okay, how about B? What did you do for B to get 121 degrees? I don't want to just hear Hannah's again. I saw Hannah kind of use the same strategy for most of them, right?
I can go.
I'm ready, Madison.
All right, so I don't know. I can't see myself. So tell me if you guys can see this.
Yes, we can. Yeah.
All right, so for B, I used, I don't know if I can say this yet, quadrants to kind of draw my angle, because I saw that it was greater than 90 degrees. So I drew like a straight line in reference. And then I saw that it was greater than 90 degrees. So I went from here to, this quadrant to this quadrant. And then I took kind of Hannah's method where I divided 90 and I guess 180 in fourths, because that's 45, 90, and then this is 135. Wait. I don't know. I drew it and then erased it. Sorry. It's not accurate. But and then I went a little below half of this quadrant to get my 121 degree angle.
Nice. Anyone have another strategy that you'd even just thought of now? You might not have used, but you're like, oh, could have done this.
I just thought of this right now. I didn't use it, but I could have. It's very similar to quadrants, and what you do is you draw a circle first, because a circle will always be 360 degrees, and you know a line straight through is 180, and then 90 is half of that. And then you can pretty much, I don't want to say guesstimate, but you can have a very good inference of what the angles are from just those three in a circle.
Nice. So notice this is half a circle right here. This is a tool, right? So if we had two of these together, which sometimes we have tools that look like that, that would be that 360 that Elaine is talking about, right? Referring to that. What, anyone have an idea what they think I did? You're like, no telling, right? I split that 90 in 3 pieces again, right? And a third of 90 is 30. 90 plus 30 is 120. Boy, I'm darn close, right? So 121. How about the 45, I think is easy, right? That was the easiest one. You're like, you should have made that one first, right? Because it would just be half of 90. How about the C, 58 degrees? What did any of you do?
I can go.
Go ahead, Sunita.
I kind of did like that, but I don't know if you can see. Hold on.
We can't see anything right now.
All right, hold on.
Now we can.
I did like little dots.
Sorry.
So I went from 10 to 90, and then I kind of just put a little bit low, like 68 or 60. Yep, 50. You can see.
Nice. That looks really nice. You guys like Sunita's idea? I like that. Excellent. And then how about this last one, this 277? Oh, what is that about? $277 degrees. Everybody just hold up your paper. There you go. We'll just make everybody suffer. Everybody hold up your thing so I can see your 277 degrees. And we can compare it to everybody else's and say, oh, that looks about the same. Are you guys looking at everybody else's? I love how you're looking at some and you're like, that does not look at all like mine. Okay. Interesting. What did anyone do for 277? It's hard to know what part we're labeling, right? That might be the hard part. So Bethel, do you think you can explain that one?
Yeah, I guess. So for me, I know that 277 is greater than 180. So so I drew a straight line first, and then I know that 270 is like an upside down like right angle. And so since 270 is close to like 277, I just went like a little bit, I'll just show you, a little bit farther to get 277. And this is where my labeling got wrong, because I put the 277 inside the angle, making it look like this angle wasn't acute. And so I realized that we're measuring the entire
that exterior angle is what
the
you're
exterior
measuring.
instead of the interior. And
very nice. So do you see Bethel's? So Bethel had hers perfect, except she had her 277 inside. Okay, so then we talked about it and we're like, oh, that doesn't look like a angle that's greater than 180 degrees. So we fixed that. Good job, Bethel. Okay, so some of you might need to rethink that 277 one. I want to show you another one. Another way to describe an angle is as a representation of a turn or a rotation, which might help you think of that circle idea. See if you can sketch, everybody sketch right now, an angle whose measure is 540 degrees. See if you can figure out how to sketch that angle, 540 degrees. Okay, and you can use this idea of a turn or a rotation. I love the confused looks I'm getting. So 540 degrees. Think about it. See how you can do it. All right, anyone have an idea? Show me what you got. Jessica put hers up there. Anybody else have one? It's okay, whatever it looks like. Oh. Oh. Yeah, so what was annoying about this? What were you struggling with this 540? This is not how you were taught angles, right? You're like, this is crazy. This isn't on my angle finder. I don't know what's happening right now. Ooh, Madison, what do you got? Madison's like nothing.
Well, I just I drew my little circle again, and then I went to 70 degrees, and then I reflected it over the x-axis again to get another 270 degrees. I don't know. That's just a theory. It's probably not right, but I was just guessing because half of 550 is 540 is 270, so that's what I guessed.
Nice. What do you think of this picture? What do you think? Yeah, so when we went from here all the way to here, that's how many degrees? When I go in one,
360.
very nice, 360 degrees when I go in a complete circle. And then I needed 180 more. So do you see how this definition of an angle helps us see connections more to a circle than just acute, obtuse, reflex? So there's more than one definition of an angle, and it's really important. So the last thing I want to talk to you about is how to measure with this tool. Yeah, this tool called a protractor, not a compass. The compass is the one with the pointy part on it that you used to poke each other with in school, right? That draws circles, okay? So you have a protractor. What makes this tool confusing? Does everybody have their protractor? I should have told you you needed your protractor. I think I did in my announcements. Oh, see, hers came with a compass, which is nice, right? Okay, so what makes this tool confusing? I don't know if you can see mine. Let me see if I can put a different color paper behind it so you can see it better. There's a lot of numbers on there. What makes this confusing? Anyone know?
What numbers are for what angle?
Thank you, right? Why do we have, like on mine, it says 50 and 130. Well, okay, so what am I supposed to use? Is it 50 or is it 130? What's happening right now, right? And then you got some other numbers down here probably because they have a little ruler. Then you got some more numbers down here. Like mine has inches on the bottom, centimeters in the middle, and then it has all my degree measurements here. So this gets really confusing. Yeah, Amanda, excellent. Both sides have 0 and 180 degrees. So here's my directions for how to measure with the protractor. And I'll make sure you have this so you could put it in your notebook. I don't think I have it in my notebook yet. You place the center point. Usually you have like a circle in the middle here where you put it on the angle's vertex, and you align. There's a line right here that you align it with the bottom ray. And then you read the angle's measure where it is on this protractor. But you might be like, well, wait a minute, here's my picture right here. Here's my picture. I put my vertex right there in the middle. I have this bottom ray lined up here. And then I can see this top ray is right here, but I can see it's between 70 and 80, but I also see it's between 100 and 110. How do I know which one to use as my measurement of this angle? How do I know which one to use?
Do you have to decide first if it's obtuse, right, or acute or straight?
I think that's a great strategy because you can use your handy dandy angle finder and you can say, oh, I can see right here that this must be an acute angle. So my number must be less than 90 degrees. That's one strategy. Anyone have another strategy of how to do it? Well, if I'm starting right here with this bottom ray must be on 0. So I'm going to start with a 0 here. So I must be going up here 10, 20, 30, 40, 50, 60, 70. So this must be 75. If I was measuring from over here, if my ray went this way and I was measuring from over here, I would start with 0. Yeah, so it just depends on what your angle looks like that you're measuring. So, and this can be a huge challenge. You can see that these go up by tens and then the little lines in between there. So then they have a little halfway mark for you, right? Like right here. So that makes it a little bit easier. So remember, we have 3 definitions. And we're going to look at this Freyer model tomorrow in class. If you want to start it, you can. You don't have to. And this is another assignment that won't take you very long. So if you wanted to try that, you can. But tomorrow, another assignment you have is to use a protractor online to do an assignment. And it's really nice because it's a nice online protractor and you're just going to screenshot it. We'll practice with our protractor tomorrow in class too, okay? I'll have a worksheet for you where you're measuring a few angles, okay? So we make sure we all know how to measure with it, but you'll get practice on that assignment. Okay, so you have, like I said, you have several assignments. Most of them are pretty short, so it shouldn't be too terrible. We're gonna work on Nearpod this week, I think. So if you've never done a Nearpod, we will do that this week during class, which will help you with some things. I'm going to put the exit ticket in the chat. I seriously don't even remember what it is. I apologize for that. I wrote it, but my memory is failing me right now. So I will pull it up too. Try it out. Oh, good. It's just naming the given angle. Got it. And spell correctly. That's it. Excellent. Okay, try that. And otherwise, I will see you tomorrow. Good work today. I will stay here if you have any questions.